So where's the problem with string theory? And again, what we're trying to do is get some arguments that people can use if they have a debate with a string theorist or with a person who defends string theorists, right? And so let's start at the beginning. Let's start where the problem started, okay? And that's with the Greeks. It all started with the Greeks. And the Greeks misconceived geometry. That's what happened. From the start, they misconceived geometry. And here it is. I can show you this. Well, you have all these Greeks. Some of them, I mean, this is not the full list, but these are some of the most important ones out there. And they believe they created, or they formalized, you could say, geometry. Geometry already was known by the Egyptians, the Assyrians, and the Sumerians. All these people already knew about geometry. But these were the first people probably on the planet, even before the Indians and the Chinese, right, that formalized geometry. And that's what you're staring at there. Some examples of what they thought were geometric figures. Except that none of what you're staring at are geometric figures according to the Greeks and according to any geometer alive today. None of this is geometry. Okay, and here let me show you why. This is what these people described. They described motion. They described itineraries. They did not point to geometric figures. Every one of the definitions that they have for geometric figures has motion. It's about points. It's about locations. That's one issue. The other one is that, you know, they extended them, like they extended lines to find angles and so on. And so what they're talking about is locations. And many locations is what we call motion. So all these figures were really constructed with motion. You know, in physics, we point to objects. We want to point to a cube, even not an ideal cube, but just a cube. You point to it, or you point to a ball, right, to a sphere. And I just show you the sphere and say sphere, and we're done. That's not what these people did. And here you can see, you know, hopefully you can compare them, right? The ones on the top is what are genuine geometric figures. That's not what they used. What they did was use the bottom ones, okay? And even to today, all these so-called geometric figures are not figures at all. They're itineraries, okay, all of them. And so, you know, geometry is about measurement. That's what geometry means. Geo meaning earth, metry meaning meter, you know, measure. So they were measuring the earth, and it's all about measurement. And that's not what geometry is. That's not what a figure is. Okay, a figure is something you point to. You point to a table, that's a figure. I don't care if it's an irregular figure, but that's how you identify objects in physics. You point and you name. That's not what they did. They defined. And whenever you define, you're defining a concept. You're not pointing, you're not referring to an object. That's the problem. And so here you have today's version of the circle, for example. This is just an example, right? Here's a Euclid's circle on the left and the modern circle on the right. What is a circle according to Euclid? It's a circle is a plane figure contained by one line such that all straight lines falling upon it from one point among those lying within the figure equal one another. And what is the circle according to Hawking, or the modern so-called physicist? A shape consisting of all points in a plane that are at a given distance from a given point, the center. In other words, what these people are doing, you know, they're still constructing their circles. Why are they constructing their circles? Because between any 2 points on the circumference, there's always another point. And so there's infinite points, to use that term, right? Countless points between any 2 points. And so these people haven't finished constructing their circles, because what they're talking about is constructions. They're not talking about finished objects, okay? They're talking about how to, in other words, what they're doing, they're giving you a recipe how to construct a geometric figure. They're not pointing to it, to the finished product. They're not telling you that's a table. They're saying, let me tell you how to construct a table. You get 4 legs, you know, a board, and you put all these nails in it. You know, that's what they're doing. That's how they constructed their geometric figures. That's why they're not geometric figures. They are, you know, constructions. That's the best word you can use for that. Okay, so let me show you what a figure is, what a circle is. Okay, so here comes the drum roll. Okay. Ta-da! That's a circle. Okay, you point to it and you say circle. That's how we do it in physics. Okay, you point and you measure and you name. That's it. And that's not what they did. And so why is that important? Because that's what they're doing with string theory. String theory, they're not pointing to a ring. They're not even pointing to a line or anything like that. They're constructing. They're constructing these things. Okay, you'll see this in a second a little more in detail. Here's one of these rings. I call them rings. They call them strings. I call them rings. Okay, forget about the SMT. It's just rings. And that's what it looks like. Okay, there's your graviton. Okay, great, no problem. Except that this is how they construct it. They have these locations all around it. Okay, this thing is moving around. It never stands still, so it's always moving. And so we have a problem because, you know, these people are not pointing to a physical object. They're saying, let me tell you how to construct a ring. And this ring is what's going to construct the particles because it's going to vibrate. Okay, and so what you're really staring at is this. I mean, you know, you're not looking at a whole ring. What you're looking at is this, how it's being constructed little by little. To use the tool that I have, which is the universal movie, let me show you how this looks in the universal movie. This is what a circle or one of these strings, closed loop strings, looks like in the universal movie. What is the universal movie? In each frame, you only have location. Okay, so all you can put is 1 point per frame, right? And here it is. You know, that's what the string theory looks like. That's what the graviton looks like according to string theory. You got 1 point in each frame, and it's moving around. Okay, so that's what a circle or what a graviton looks like. Now you know. Okay, so you can see some of the problems that we have because the string is not a physical object. You cannot say that particles are really vibrating strings, partly because, you know, these strings are being constructed themselves by all these points. You know, especially if you have a line, you know, what is a line made out of? Points. What are those points? Locations. What is several locations? Motion. That's what you have. Or locations of different objects. One of the two, right? So here you have the strings, okay? Once again, okay, you have all these particles, and they're made out of these circles, these rings, okay? There you see them, okay? That's what they're made out of. And so the question is, you know, does a particle, which, you know, you think of a particle as a ball, as a thing of some kind of sphere. That's how it's always illustrated. How does that relate to a ring? And here, let me show you, illustrate what I'm saying here. That's a particle on the left. That would be like a quantum particle. That's what someone would draw for a particle. And on the right, what you see is a ring, which is what string theory proposes. Well, how is a ring like a particle? That's the first question. And are we saying that that ring, which is a 1D line, according to these people, right, which is really an itinerary, but let's forget about that. Let's assume it's a line. It's a 1D line, meaning all you have is 1D, but now they've turned it into a 2D in the sense that, you know, it goes into at least 2 dimensions. And the question is, how does that relate to a particle which allegedly is 3-dimensional? And what does it have to do with physics, which only deals with three-dimensional objects, what exists? And only 3D things exist. 2D things do not exist. They're always of something else. Like, a plane, such as a square, is part of a cube. That's what it is. Okay? So we have a problem with all these people using a ring to represent a ball. And they say it does represent a ball because it vibrates. I don't care if it vibrates. It's vibrating in 2D, even if it moves in 3D. How does it, unless it twirls around, which again is just at any point in time, in any frame of the movie, all you have is a ring. So how does that construct a 3D object? Okay, so again, they want to construct their particles with motion. That's what they're doing. And the particle they're using to construct it, which is the ring, is also being constructed by motion of something going around it. And this thing also twirls. Okay? So they have all these misconceptions, you cannot make sense of any of that. You cannot rationalize what they're saying. And here, let's continue with some more nonsense from the string theorists. Which is the mechanism they propose. Here's on the left, you have string theory, gravitons moving through space-time. That's what they're saying that the gravitons do. How does that relate to relativity, which says that the warping of space-time is what causes gravity? They're never going to be able to reconcile these two notions, these two explanations, these two physical mechanisms. So, again, string theory is a non-starter because they cannot conceptualize it before they go out there and do their math. What are they doing their math for? It's all worthless nonsense. Okay, what they're doing today, all their equations are worthless. In what way can, if they cannot reconcile quantum mechanics with relativity through string theory, because string theory is misconceived from the start, then all these people are wasting their time doing all these equations. It's just worthless work. That's what it is. And here we have this gentleman. His name is Brian Cox, and he's going to tell us something else, which is, right now you should go get a beer and come back, because what Brian Cox is going to tell you is that, where do all these gravitons go? They disappear. They're like the virtual particles. They come in from nowhere and go out somewhere. Where did they go? And he's going to tell you, Ryan, okay? Here it is. Listen to him.
If gravitons are created, the reason why they would disappear is because they vanish into a place beyond our reality, into some sort of extra dimension. There can be extra, hidden, unseen dimensions. Gravitons, the particles of gravity, can spend most of their time in those extra dimensions.
Okay, so they go off into other dimensions. And I guess you got to drink a lot of beer to find out where those dimensions are. These people have no clue whatsoever what they're even talking about anymore. It's just total nonsense. I call it not dimensions. I call it dementia. That's what it is. A lot of dementia. That's what they have. Okay, so here we have, the head honchos, the gurus of string theory, people like Ed Witten and Leo Susskind. And these people, they're worshipped. They're celebrities. People say, oh, look how much knowledge they have. They're so intelligent. They're so smart. They know all those equations. Well, what can I tell you? I have no respect whatsoever for these people. None whatsoever. Or better yet, I treat them with the respect that they deserve. And since we're talking about mathematics, I guess we can say it's negative respect. I'll put a negative sign in front of it, right? Here's a couple of these people. Again, Leo and Eddie. And this is what they're working on, They're working on 11 dimensions. They talk about peep brains in 11 dimensions. They create all these concepts, worthless concepts, because they have nothing to do with reality, with physics. But this is what they're working on. This is what they're developing equations for. And they invent new language, irrational language. All of it is irrational. Not one word of their language, of their lexicon, survives. Here they're working also not only on 11 dimensions, they also work on 0 dimensions. They have also objects which are 0-dimensional. And here it is. Graphical illustration of a 0-dimensional space is a point. And what is a 0-dimensional? Well, it's a topological space that has dimension 0. I like that. Okay, dimension 0, whatever that means, with respect to one of several inequivalent notions of assigning a dimension to a given topological space, whatever all that means. 0-dimensional means it's got no volume, no nothing. We don't deal with 0-dimensional because 0-dimensional, no object's 0-dimensional. It's nonsense to talk about something that has no length, width, or height. Okay, we're talking, or time for that matter in their case, right? But we're talking about nothing. 0-dimensional is the definition of nothing. Okay, it says a topological space is 0D with respect to the, and it's got 3 conditions here. One is Lebesgue covering dimension of if every open cover of the space has a refinement that is a cover by disjoint open sets, whatever that means. Another one, finite to finite covering dimension if every finite open cover of the space has a refinement that is a finite open cover such that any point in the space is contained in exactly one open set of this refinement. I hope you understood all that. And the last one, small inductive dimension if it has a base consisting of Clopin sets. What's a Clopin set? Well, it's a set which is both open and closed. Okay, so now you know, okay? I hope you understood all that. Okay, we'll be on the test on Friday. Yeah, these people had to invent irrational concepts and irrational language. And people say, oh, he must be so smart because I didn't understand squat. Exactly, yeah. If you didn't understand squat, you're more intelligent than they are because they should be able to make themselves understood without all this nonsense. And the question is, well, any of that, how can it explain what causes the spoon to fall downwards? That's all they had to explain. This is kindergarten stuff. This just requires that you visualize, because you can't test it, you can't go to the lab and run an experiment. All you can do, you cannot see or touch it, so you can't use your hands or your eyes for this. All you can do is use your mind. You have to figure out why this thing falls downwards. For that, there had better be some physical entity here that we cannot see or touch. Just like when you have 2 magnets, right? They touch each other and they stay together, right? And there's something here that we cannot see or touch. And if you say there ain't nothing there, we got a problem, because then you're saying, look, you can see it here. Try to do this. You can see how it's pulling already. And so there's something there in between them that we cannot see or touch. People say it's the field. Field is not a physical object. You cannot use the word field. It's an irrational term. You cannot use the words energy, field, mass, time, or force. None of those 5 words, or charge. Let's put a 6th one in there. You cannot use those words in science, in physics. Anyone using those words is an irrational individual, because what they're doing is using a concept as a physical object. Okay? There is no such thing as a field. Field is a concept. It's a value at each point in space. That's how it's defined. You don't like the definition? You want to define the word field as a physical object? You can't define it as a physical object. You have to point to it. And all fields are infinite, so according to the official version, right? So we got a problem. You can't use the word field. You have to identify what physical object is inside that region we call field. That's what it is. Okay, so what else do these people do? Well, here's open strings and D-branes. This is what these people work on. This is what they develop equations for. Open string, an extended one-dimensional object. Absolutely not. It's not an object. Open string is a one-dimensional. There's no one-dimensional object in the universe. Okay, there's no such thing as a one-dimensional object with two endpoints, right? Endpoints are not freely floating, but are attached to branes. And they say higher dimensional surfaces. Again, a brane is not a surface. It's a plane. Plane is not a surface. The word surface belongs to the world of 3D. The word plane belongs exclusively to the world of 2D. One is two-dimensional. Surfaces are always three-dimensional. There's no such thing as a two-dimensional surface or higher dimensional surface, whatever that is. The open string itself represents a field excitation. No, we don't excite fields because fields are a bunch of numbers. It's defined. The word field is defined as values at each point in space. So you cannot excite numbers. Okay? You don't like the word field as numbers, you got to redefine it. And you better not define it at all because you got to point to it. Okay? So that's the way it works. If you want to excite it, it better be a physical object. For that, you got to point to it, okay? It's a vibration or a wave on the surface of the brane, not a physical string connecting two separate distinct surfaces. Yeah, none of what you see in string theory is physical at all, okay? It says D-branes, a class of extended objects. No, they're not objects, upon which strings can end. It's an object, it is an object if it's a 2D plane of some kind, okay? But the problem is these people construct them. And when you construct, it's not an object. Now you're talking about the motion of something. And that's why a D-brane is not an object, okay? Because it's constructed. A D0 brane is a single point. A D1 brane is a line, also known as D strings. And a D2 brane is a plane. Okay, so they have all these concepts. I don't know why they had to invent all that garbage, all that lexicon, all that jargon. I mean, what was the point of that? We already had planes. If you were looking for a square, right? Well, you didn't need to invent the word brane, okay? Because that's essentially what they're talking about. Or maybe it's a round one. Maybe it's a disc of some kind, okay, circle, whatever they want to call it. We didn't need to invent new words just to confuse people and say, I'm studying string theory. Oh, what is that about? Is that about planes? No, it's about brains. Oh, Jesus. So high, so beyond my capacity to understand that. Yeah. It doesn't stop there. Here's what they call winding number. Remember this rubber band? It goes around and around and around. The number of times it goes around is called the winding number. And here you get an idea of that, okay? Winding number of a closed curve is equal to the total number of counterclockwise turns that an object makes around an origin, okay? In other words, the curve's number of turns around a given point. The rubber band goes around and around, passes the same point. Every time it passes the point, one number, okay? So go 3 times and you have, 3, positive 3 if it's counterclockwise, negative 3 if it's clockwise. And so whatever that helps in any way, right? Closed curve, the mapping of a circle. Yeah, closed curve is a circle. So I don't think they invented anything there, okay? And so they have all this new language that they've developed. Here's a illustration of the winding number, okay? So you can get a better feel for what they're talking about. You can see here how this is going, right? It's going in curling around, going around in different directions. And if it goes clockwise, it's, again, negative. If it goes counterclockwise, it's positive. And there you see some specific examples. -2 and -1, you can see the arrows. Either it goes twice around, so that's the winding number. And it goes one time around 1, so it's a -1. And if it goes counterclockwise, you have the 1, 2, and 3 there. Why we need this nonsense to explain gravity, only God knows, None of this will give us any notion of why this spoon falls downwards. That's all we want to know. And what these people do is develop equations with all this stuff. with winding numbers and masses and energy and all this stuff that has nothing to do with the question we're asking. We just want to know why the spoon falls to the floor. That's all we want to know. We don't want to know about black holes. We don't want to know about Big Bang. We don't want to know about dark matter or dark energy. None of that. All we want to know is why the freak a spoon falls to the floor. That's all we want to know. Okay? We want to know the mechanism. And for that, hopefully every atom of this spoon is connected to every atom on Earth. That's the reason it's being pulled downwards and doesn't go upwards towards the ceiling. A lot more atoms down below than above. Okay, so here another thing that they have, the T-duality. That's what they study. This is what their developing equations was. It's called the target space duality, and here it is. Okay, T-duality, two theories, quantum field theory and string theory, are mathematically different descriptions of the same phenomenon. That's it. And so they create these terms, like T-duality. They say, oh, look, I've invented something new. Why do we need all this nonsense? Why do we need this if we just want to understand how this universe works? This does not give us any insight into how the universe works. Father Universe is just a bunch of atoms. That's all it is. And, and every atom is at a distance from all others. So if we take a snapshot of the universe, we have a single frame in the movie, right? All atoms are there in the universe. God's camera, right? All atoms are a given distance from all others. That's a single frame in the film. Next frame, all atoms have a different location, okay? So what we need to figure out, what is in a single frame? What are all the objects, all the atoms, all the neutrons, whatever is in the single frame, right? And none of this is going to help us reach that, an answer to that question. So one of the theories describes strings propagating in a space-time shape like a circle of some radius r, okay? While the other theory describes strings propagating on a space-time shape like the circle of a radius proportional to 1 over r. And that's what they call the T-duality. So they create all this nonsense. Like saying, we can get this equation from two angles. We can do it from the point of view of quantum mechanics, how quantum mechanics would do it, or we can do it from the point of view of string theory. If they describe the same phenomena, then they have this T-duality. Great. Love it. Who cares? What does it have to do with anything? Okay? And here you have Matt O'Dowd, and he's going to tell you something about, the fact that, these strings originally were designed to connect any two particles out there. And here, listen to him, okay? Here goes.
Peculiarities in the interactions between pairs of mesons, as well as an odd relationship between their angular momenta and masses, suggested that the quarks in mesons are connected by, you guessed it, strings. In this case, the strings are stretched out tubes of strong nuclear force, vibrating elastic bands made of gluons.
And he's not the only one. Here's another fellow who says almost exactly the same thing. They had these strings that connected any two particles. Sounds like they're talking about the rope, They realized that they have to connect these particles physically. And then they decided to reject it on the basis of math. Okay, but here it is. Listen to this fellow. He's going to say more or less the same thing.
Scientists theorized that the quarks and mesons may be connected by strings which were believed to be stretched out tubes of the strong nuclear force.
Why did they reject them? Because they were talking about the strong nuclear force. No, you don't connect two particles with force. Force is not a physical object. It's an irrational mathematical concept. That's what it is. It's irrational because they're using this number as a physical object. That's why it's irrational. You cannot do that in physics. You cannot bring your stupid math into physics. In physics, we do not use math, okay, at all. We have no use for math because physics is about explaining. Physics is about explaining how this universe works. We do not describe it, which is all that math can do. So we do not use math in science or in physics. Math is a language. It's a language that can only describe. It has no ability to explain, and it has no ability to tell us what exists out there. Okay, so anyone using math is not a scientist. Okay, and these people, that's all they do all day long. They go into string theory, which is all math. It's just math taken to ridiculous levels, unnecessary levels, irrational levels. And then they try to, with that math, to try to explain how the universe works. You can't do that. You want to know how the universe works, you need to use objects. You need to use things. Father, the universe only works with things. He doesn't know anything about, he never went to school. He doesn't know anything about math. Okay, so math is something idiots known as humans invented and has nothing to do with how the universe works. You need to find out what exists out there. And we do not describe, we explain. In order to explain, you need to identify the objects. Otherwise, you cannot explain a mechanism. You cannot explain why, what causes this spoon to fall to the floor unless you identify the physical objects. We do not use any math whatsoever to identify why. Cause, mechanism, this falls downwards. Okay, just as simple as that. And so this is the issue. And it turns out that once they put all these connections between, the mesons and so on, they still use these bed springs, the gluon bed springs between the quarks. And what are these bed springs? Well, it's just math. Again, it's more math and math and math and more math. And we don't have an explanation for what that gluon bed spring is. So they put it in there by hand, and they say, yeah, the gluon prevents the quarks from flying apart. Well, yeah, I mean, if you put a bed spring in there, we all understand that. Is that what a gluon is? A bed spring? I don't see it in the standard model. In the standard model, I don't see bed springs. I don't see waves, right? All I see is dots, particles, and not a single one of those has ever been seen or proven to exist. They're theorized, they're hypothesized, but you cannot explain anything with particles. You cannot explain a single phenomenon of nature with particles, with discrete particles. Not one. Okay, listen to what I'm telling you. You cannot explain a single phenomenon out there with particles. Particle has to die. The particle hypothesis is what the mathematicians use because a particle represents a number. That's why. It's a single point, and that's what they're going to put in an equation, a number. And so energy is a point. Field is a point. A particle is a vibration of a field which they designate with a point, and so on and so forth. Why? Because they put a single value in the equation. That's all math. It's got nothing to do with physics. Physics, you need objects. You need to move objects around. You have to show me a mechanism. If I have an engine, a motor, right? I don't need any math to explain to you how it works. I don't need to know how much force, how much energy. I don't need any of that. I just show you mechanistically how, that thing works. And for that, I need all the objects, that make up the engine. I have to identify every piece of it. That's the way it's done. And that's what we need to do with, gravity and with magnetism, for example. I need to explain what's causing this. I can't use the word energy. I can't use the word mass. I can't use the word charge. Can't use the word field to explain what causes this to be attracted to that. And that's what nobody figured out because they're all mathematicians. They've been doing math for the last 400 years. Not a single one can explain why this spoon falls to the floor. It's just unbelievable. This is kindergarten stuff. All you needed to do, identify the invisible, intangible objects that mediate that transaction. Okay, so what do these bozos do? Well, lately they work on singularities, black holes specifically and Big Bang, because those two have singularities at their root. And the reason they like to use string theory is that it avoids infinities. Okay, so these people like string theory because the equations that they're using are not like quantum or general relativity, which are plagued with infinity. That's when they say, oh, the laws of physics break down at the singularity. And if they're going to work on black holes, which there's no such thing as a black hole, it's a singularity, right? No such monster as a black hole. But even if there was a black hole, how does a black hole, which is just all mass and no body, how does a black hole affect a star which is millions of miles away? By what physical mechanism? By action at a distance, again? Or are they going to go through the field? Are they going to go through space-time, which is just number lines, mathematical number lines? Is that what the mechanism is? You bend the number lines, you bend time. I mean, this is all idiocy that's coming out of mathematical physics. These people might as well, work on this. They should work on leprechauns, inventing equations for unicorns, ghosts, goblins, spirits, or witches. What say you? You agree with me? Is this what they should be working on? I mean, the worst part is these people are spending your tax dollars. You're paying for them. And these people will make big bucks, believe me. For what? For developing math to ridiculous levels, to unnecessary levels? What are these people making money for? What are they giving you in return? If you were running a company with these people, you'd go out of business in a week. Maybe you wouldn't even last a week. Anyways, just too many problems with string theory. The arguments essentially are strings are not physical objects, okay? They're rings, not strings, they're rings. And a ring is made out of motion. And then the ring makes up, because it vibrates, the motion vibrates and makes up the particle, right? So it already fails there. But even assuming we concede the string, okay? Let's concede it as a physical object. Okay, so you got a rubber band there that's vibrating. Great. How does that rubber band pull? How does it pull? Give me the mechanism for how these rings bring the spoon downwards. That's what I want to know. Okay, smart Alec, show me how your math. Don't show me your math. I don't care about your math. I want to see the physical mechanism, how your rings, pull on this spoon. And you can't do that. And then again, you have a contradiction between the rings flying through space-time and general relativity, which we're trying to reconcile, quantum mechanics with general relativity. Why in general relativity you have warp number lines? Warp number lines has nothing to do with gravitons flying through the number lines. So those are two different mechanisms. So they're never going to be able to reconcile one with the other. So from every point of view, string theory just fails. It fails conceptually. So whatever math they develop for it is irrelevant. It's taken to ridiculous levels, unnecessary levels, irrational levels. That's what string theory is in a nutshell.